So today we're going to talk about the idea of theoretical yield. And theoretical yield is simply how much of a product will be made under ideal conditions. Okay, so if everything is perfect, how much of a product can be made under ideal conditions. Okay. So if everything goes exactly as it should, this theoretical yield, right? So how much you can make in theory or how much you can yield in theory. Okay. So this type of problem is almost always going to be a grams to grams problem. So if I start with this many grams, how many grams can I make? Okay, so this is going to be a grams of A to grams of B problem. So you're going to follow your flowchart to do this type of problem always, okay, as a grams of A to grams of B problem. So the amount of the product that you can make under ideal conditions, that's theoretical yield. So we're going to use an example here, okay? And I'm going to pull in this reaction, and this reaction is a common reaction that you have probably seen before, that we've done in class, and it starts with some baking soda. Okay, so this NaHCO3 is simply some baking soda, and you can guess that that's going to react with some vinegar or some acetic acid, and we have three products. We have a NaC2H3O2, which is sodium acetate, water, and then obviously the lovely bubbling that we get is caused by the carbon dioxide gas. Okay. So typically when we have a theoretical yield question, it's going to look something like this. Okay. It's going to be asked in this format. So if you start with the 5.0 grams of sodium hydrogen carbonate, also known as baking soda, what is the theoretical yield of sodium acetate? That's this right here. So when it says theoretical yield, remember that that should be implying grams. Okay? Whenever you see theoretical yield, we're looking for how many grams theoretically should I make if I start with 5 grams of this. So my equation here is already balanced, so I don't have to worry about going through and doing that again. But what I do want to do is label my given and what I'm trying to find, just as I would in any stoichiometry problem. So if I start with this, okay, this is going to be my A, it's what I'm starting with. I'm starting with 5.0 grams of it. The next thing I want to do is I want to label my B, and the B is what I'm trying to find. And in this case, that's my NaC2H3O2. So I'm going to label that B, and I don't know how much of that I have. That's what I'm trying to find, and because I'm looking for the theoretical yield, that tells me that's going to be in grams. So if I look here, this is just like any other stoichiometry problem that we've been doing over the last few days. Only we're looking, right, it's worded a little bit different. We're looking for a grams to gram situation here. What's the most that we could make under the best conditions? One thing you'll notice about these problems is they're always going to start with A will always be a reactant, and B is always going to be a product. So you'll always start with a reactant and figure out how much of the product can I make, one particular product. So we're interested in this for some reason. Okay, so usually in a theoretical yield question, we're looking for how much of this can I make, because that's the important part. We might make water and carbon dioxide, but our most important reactant, or product, that we're trying to get from here is going to be the sodium acetate. So we want to be able to measure the grams of that. So I'm going to set this up again, just like I do any stoichiometry problem. Okay. I'm going to pull in my string here, and I'm going to go to my string, and on my string I always want to start with what I'm given in the problem. So I'm going to go up to my A here, and notice that I'm given 5.0 grams of sodium bicarbonate, or NaHCO3. Okay? And remember to label those units with a unit and the thing. So that's what I'm starting with. The next step for me to do is to go to my mole flow chart. Okay? And if I look at the mole flow chart, I'm going to see that I need to go first from grams of A. Okay, so I'm going to model this here because I don't have the flow chart in front of me. But grams of A, and the first step is going to be moles of A. Okay? And this here is coming from my flow chart again. So you're going to get this from your flow chart. So the grams of A, I know that I need to first go to moles of A, and then I need to go to moles of B, okay, and then I'll finally get to my grams of my B. So to do this type of problem, if I look at my flow chart, I'm going to need to go grams of A to moles of A, moles of A to moles of B, and then moles of B to grams of B. So I'm going to start by going to moles of A. And what I need to do that, if you look at your flow chart, it'll tell you it's going to be the molar mass. So I've already calculated the molar mass of this substance here, of baking soda. And the molar mass of baking soda is 84.01 grams of NaHCO3. Okay. So I've calculated that's my molar mass, and I know that the molar mass is the number of grams in 1 mole. Oops, NaH. So by setting it up this way, I've put my grams on top with my grams on the bottom of the same thing. These are both baking soda, so I can cross those out. Okay, and now I've gotten to this step. So I've gotten through, check, right? I've done this step. I'm now here. Okay, I'm going to move on now to my moles of B. So I've got moles of this, and I need to get over to moles of this. And the only way to do that is to use the mole ratio. Now our equation is balanced, and notice there are no coefficients in front of any of the reactants or products. So the mole ratio in this case, that means is that it is a 1-to-1 ratio. So I'm going to put the mole ratio of what I've got, which remember is 1 mole of NaHCO3. Right? Oop, my pen's having some issue there. 3. Okay. So that's going to go on the bottom. Remember, that's what I've got. On the top, I want to put what I want. So what I want to find, again, is my B, which is NaC2H3O2, sodium acetate. Okay? And that sodium acetate, I know I've got 1 mole of this for every 1 mole of that, because I have no coefficient in front to tell me any different. And I already have it balanced here. So 1 mole of NaC2H3O2. So far I've got those cancel out there. I used my mole ratio now to get from point A, moles of A, to moles of B. So according to my flow chart here, I've done the first step, I've done the next step, I've got one more step. I'm at moles of my B here, of sodium acetate, but I need to find grams of B. And my grams of B, again, I'm going to need to use my molar mass. But this time, I want the grams to go on the top, because whatever you're trying to find should always go on the top. So the molar mass of this, I've already calculated, okay, is 82.04 grams. And that is NaC2H3, it's going to run together here, O2. So that's the grams I have in 1 mole of that. NaC2H3O2. So my moles of sodium acetate cross out, and I'm left with grams of sodium acetate. So that's pretty straightforward. Now I can take that and I can put that into my calculator and I can solve. So even though it has a fancy name, it's called theoretical yield, there are several similarities to what we've already been doing. So I'm just going to take my calculator here, I'm going to put it in. So I'm going to start with my 5 from the first block here, 5.0. I'm going to times that by 1, because I'm multiplying across, divided by 84.01, times 1, divided by 1, again, and then times my 82.04, and then divided by 1. That's going to get me 4.88 grams. Okay, I'm going to round that to two significant figures, which should give me, okay, let me change colors here, so I have, it's going to be equal to 4.9, if I round that to two significant figures, grams of sodium acetate. So that's my final answer, 4.9 grams of sodium acetate. So that's the theoretical yield. Okay? How much of a product that can be made under the ideal conditions. So I'm going to expect that if I start with 5 grams of NaHCO3 or baking soda, I'm going to make 4.9 grams of sodium acetate. So I'm going to look now. Okay? We know that this is the ideal condition, so that's our theoretical yield. But in reality, we don't really undergo those ideal conditions. So in the next video, we're going to take a look at the percent yield. Okay? How much do we actually get out of the theoretical yield?